Hi everyone, welcome back to my channel. In today's video, we'll revise all important string related concepts related to interview question and answer. So, first question is, what are the ways of string creation in Java? So, before that, let's see how to create objects in Java. So, normal object we can create using 5 ways: using the new keyword, using class.forName, using clone, using deserialization, using new instance method in reflection. Now let's see what are the ways to create a string. So there are two ways to create a string in Java. First is using the literal. Once we create the string using the literal, that is string s1 equal to hello, it gets stored into the SCP, that is string constant pool. Another way is using the new keyword. When we create a string using the string s2 equal to new string, in that case it gets stored into heap memory. Now, string constant pool. Let's see what is string constant pool. So it is a spatial memory area inside the heap, and it is generally used to store unique string literals. If we create the same strings using the literals, the SCP will not create two different strings. It will point to the existing string. It will take reference of existing string only. So duplicate literals share same reference. What is intern method? So intern method is in Java, every time we create new string using new keyword, it goes into the heap memory. Even if an identical string already exists in a string constant pool, it creates new string in heap memory. So intern method helps us to avoid the duplicate string objects. When we call an intern on a string, Java checks if that same string is already present in SCP. If it exists, it returns the reference of pooled string. If it doesn't exist, it adds string to the SCP and returns that new reference. So basically, intern makes sure that identical string values share the same memory space. This saves the memory space and follows a faster comparison using the equal to comparator. So for example, we have a string s1 equal to new string hello, and again we have string s2 s1 dot intern. So s1 is a separate object in a heap, and s2 it will create the same object in SCP as well. So when we compare the references for S1 and S2, it will be false, but the content is same. But if the string is already present in SCP, in that case it will point to the same reference from SCP, even if we created that using the new keyword, because we are using intern method on that object. Now let's see compile time versus runtime concatenation. When both the strings are literals, the concatenation happens at a compile time and the result is stored into SCP. But if one of them is a variable, the concatenation happens at a runtime and the result goes into the heap memory. So compile time saves memory while runtime creates new object. Here in the example you can see string s1 is equal to two literals are there, hello and Java. We are concatenating that using the plus operator. It will go to the SCP. While runtime concatenation, we have another example. String s1 is hello and s2 is s1 plus Java. So s1 is a variable. We are using variable when concatenating the strings. That's why it will go to the heap. memory. So let's revise once. If string is created using the literal, it will go to the SCP. If strings are created using the new keyword, then it will get new object on a heap memory. Intern method is there to move um, object creation to SCP instead of heap memory. Equal to operator is there, compares the references. Equals method of string is there, which compares the content of string. Now let's see a few examples which are important interview perspective. First one is, if we have two strings with the same content and created using the literals, the s1 equal to s2 will be true. Equals method will return true. In storage perspective, it will get stored into the string constant pool. Another is, if two strings are created using the new keyword, the references will be different. Content is same. It will get stored into heap memory. Next is, if one string is created using the literal and another is using the new keyword, the references will be different. If the string content is same, then equals will return true. Storage perspective, S1 will get stored into SCP and S2 will get stored into heap memory. Next one is, if one string is created using the literal and another is concatenating that string with a variable, in that case, equal to will return false. Equals will be false because two strings are different, and it will get stored. S1 will get stored into SCP and S2 will get stored in a heap memory. Next example is, if string S1 is created using the new keyword, but again we are using the intern method on that, and S2 is created using the literals. As we have used intern method, the S1 will get stored into SCP only and S2 will get stored in SCP. So references will be true and data is same, that's why equals method will return true. Storage while it will get stored into SCP. Next example is, when S1 is created using the literals, concatenation of literals, S2 is created using the literal only. So references will be same, content is the same, storage will be SCP. Next example is, when S1 is created using the literal Java plus 123, 123 is not a string, and string S2 is Java 123. But here we are concatenating at compile time. So both strings will get stored into SCP and their references will be same and content is already same. Next example is, integer x is 1 to 3. S1 is concatenating with x, Java plus x. So it is a runtime concatenation. So S1 will get stored into heap. S2 is literal string. So it will get stored into SCP. When we compare the references, it will be false. And the content is same, so equals will return true. Last example is, S1 is created using the literal plus new string b and S2 is AB. So S1 is S1 will get created into heap because we are concatenating with new string b. In that case the references will be different, but the content of the string is same, that's why equals will return true. So these are the important example interviewer might ask you regarding the string. Now the next question is, why string is immutable? And we can do the custom immutable class as well, that also we can see. First we'll see why string is immutable in Java. So string is immutable for Security purpose, it prevents the modification of a data. So we can use that in class loading, URLs, password strings, and all. Second is thread safe, safe for multi-threaded environments. Third one is hash code caching, improves the performance in hash map. SCP optimization allows reusing the strings. Now let's see how we can create our custom immutable class. So there are a few steps for that. We can declare our class as a final, make the fields as a private and final. No need to include the setters. Initialize the data using the constructor and return defensive copies of getters. Let's see example of immutable class. Here is a simple example. Notice how the class is final, fields are private and final. The constructor copies the mutable inputs. That's how you can make sure no one can modify your object after creation. We have multiple functions of a string, that is inbuilt function. We can go through that functions and find out the purpose of each function. Some important methods you must remember, like a character at length, index of substring, replace, stream, equals, compare to uppercase to lowercase, and enter. So these are the most frequently asked interviews. So strings are immutable. Let's check mutable version of a string. So we have string builder and string buffer. What is a string builder? Mutable sequence of characters, not synchronized actually, optimized for single threaded string construction. Another string buffer is there, which is used for mutable sequence of character. Generally, we use it for a multi-threaded environment. It is synchronized, thread safe for use by multiple threads. So when should I use string? Use when the text is constant or rarely changed. Constant map keys config values. The text we generally want to be constant, not changeable. In that case, we can go for a string. If thread safety is required, we can go for a string buffer. And for in case of a string builder, use it for building or modifying the strings frequently in single threaded context. Next is what are the main benefits over plain text of the string builder and buffer. If you're a temporary object, lower GC pressure. GC is garbage collection. And for better performance, for repeated modifications, we can go for string builder and buffer as per the context. Regarding performance tips, prefer string builder for speed, precise capacity with new string builder to reduce the resizing. We can give the estimated size to reduce the resizing. Thread safety tip. Do not share a string builder across the threads. Prefer per thread builders and merge result or use concurrent design instead of shared string buffer when possible. So in multi-threaded environments, string buffer is better than string builder. So this is the main difference between the string builder and buffer, when to use what. So that's all for today's session. Please like the video, subscribe, hit the bell icon so you don't miss the next concepts. Thanks for watching the video. Keep learning and stay confident. Thank you.